Well, hey, everybody. Welcome back to the Dr. Jocker's Functional Nutrition Podcast. Guys, I'm excited about today's interview. I've got Dr. Ben Bikman here. He is a professor of physiology and developmental biology at BYU, and he's the author of Why We Get Sick, the Hidden Epidemic at the Root of Most Chronic Disease and How to Fight It. Really great book, guys. If you want to dive into insulin resistance, ketones, inflammation, I mean, it's just a powerful book. Lots of really great content, a lot of great diagrams and images. Absolutely love the book. And so Dr. Ben's research focuses on molecular mechanisms that mediate the disruption that causes and accompanies metabolic disorders, things like obesity, type 2 diabetes, and dementia. Driven by his academic training, he has a PhD in bioenergetics and a postdoctoral fellowship with the Duke National University of Singapore in metabolic disorders. He's currently exploring the contrasting roles of insulin and ketones as key drivers of metabolic function. He frequently publishes his research in peer-reviewed journals, presents at international science meetings. A lot of really good content on Dr. Bikman on YouTube that you can find as well. And I'm excited to have you on the podcast today, Doctor.
David, thanks so much. I'm thrilled to be here. Glad to talk about anything metabolism, and I hope the listeners find some gems they can take away with.
Yeah, absolutely. Well, I loved your book, and so let's start with that. What inspired you to write it?
Yeah, thank you. The book was really an effort for me to highlight what I believed to be something we were overlooking in medicine. And that was that so much of these diseases that we were all worried about, far from being each a completely distinct and separate disorder, were mostly either entirely or to some large degree actually derived from one common problem, in fact, a metabolic problem, namely insulin resistance. So really the book, the purpose then, having said that, is to kind of make the case for insulin resistance as being relevant in any discussion or any queries into health, so essentially explaining what is insulin resistance and why does it matter. So what are all the diseases that come from it, and including several that you just mentioned, and then follow up with that, looking at the causes of insulin resistance. Where is it coming from? Why is it the most common metabolic problem in the world? What is it about our environment that's got us here? And then the last third of the book is the solutions part, the what to do about it. So basically from front to end, someone will come away with an understanding of what is this most common health problem and why and how is it so relevant to every other chronic disease. And then from a practical standpoint, my hope is that someone would read the book and then have a different understanding with regards to their own health. They may look in their medicine cabinet and see that they're taking a distinct medication for their blood pressure, a distinct medication for their migraines, a distinct medication for their infertility, and then realize after having read the book, each of these is a symptom or a manifestation of one common problem, and that one common problem is best treated not by any medication, but by lifestyle changes. Because indeed, insulin resistance, the most common health disorder, is a result of lifestyle. So the way we eat or live is either going to be hurting us or helping us.
That's really great explanation. And so let's start by talking about what insulin is, what kind of role it plays in the body, and how insulin resistance develops over time.
Yeah, so insulin itself is a small little hormone that is made from the pancreas in our bodies. And everyone is making insulin unless you're a type 1 diabetic. The disease in type 1 diabetes is the loss of those cells that make insulin. So that's what insulin is. It's a small little hormone just flowing through our blood. Importantly, there are insulin receptors on literally every single cell in our bodies. Every type of blood cell, red and white blood cells, every type of cell in our joints, in our bones, our liver, brain, you name it, every one of those cells has an insulin receptor. And an insulin receptor is essentially a small little docking site on the surface of a cell. And insulin, as it's flowing past these cells, it will come and bind onto that receptor and then tell the cell to do something. Now, whatever that something is depends on the cell. So one of the most common perspectives with regards to insulin is to look at it strictly through the lens of glucose control. And that's relevant, no doubt. If glucose is going up, the body cannot tolerate elevated glucose for too long. Indeed, it becomes lethal. It is dangerous to the body. And so insulin comes up and it starts to push the glucose, so to speak, from the blood into the body cells, most especially muscle cells and fat cells. Indeed, muscle is the main consumer of that glucose uptake as insulin starts pushing it into the muscle. So that's one of the main features of insulin, without a doubt. But to only look at insulin through the lens of glucose control is really unfair to insulin, because it does so much more with regards to maintenance of nerve structure, the production of myelin on neurons, the maintenance of muscle and bone mass and joint function, brain energy utilization. There's so much that insulin does throughout the body that we need to appreciate its role beyond glucose. And that's another outcome of the book in a way. It is to just appreciate the incredible amount of processes or cellular events that insulin has its hand in. And then as we look at that, move from the context of healthy insulin functioning or the insulin sensitive body to insulin resistance, this term that you and I have both mentioned now a few times, insulin resistance is best understood in a disease state, a clinical state, as really being a function of two things. One is that insulin isn't working quite the same way as it used to throughout the body. So some of its signaling at certain cells is altered, but in some ways the signaling is unaltered and it continues to signal perfectly fine. But that becomes itself problematic in light of the second problem of insulin resistance, which is hyperinsulinemia. Insulin is elevated in insulin resistance. So that high insulin, combined with insulin not quite working the same way in all the body's cells, that creates the two pillars of insulin resistance as we know it in a clinical setting.
Yeah. And so basically, one other element with insulin is when we have uncontrolled blood sugar, we end up getting these glycation end products. And so insulin basically helps prevent, and that's really toxic to the body. So those high levels, so it protects us from high blood sugar, which again, those glycation end products, advanced glycation end products, those AGEs, damage our kidneys like shrapnel going through the bloodstream, damage the kidneys and nerves, right? All those different areas. And so you got to have the right amount of insulin output to help regulate that in the system.
Yes, that's exactly right. Yeah, well said. That is an appropriate consideration when we look at the pathological side of too much glucose. Insulin, lest anyone misunderstand me, insulin is absolutely essential in any number of ways, in so many processes, and even in the context of just maintaining glucose, it does prevent that hyperglycemia mediated problems like these formation of the advanced glycation end products, which are very relevant in chronic hyperglycemia, very likely explaining much of the pathologies that we see with neural problems and blood flow problems like that which accompanies type 2 diabetes very typically.
Yeah, absolutely. Let's talk about the difference between being a fat burner and being a sugar burner. Let's go into that.
Mm-hmm. Yeah. That's something I really always enjoy highlighting because too few people appreciate human metabolism in its kind of hybrid glory. And you touched on this. Human metabolism is basically fueled by, two main sources of energy: glucose or blood sugar and fat. And at any moment, the body is obtaining virtually all of its energetic needs from a mix of those two fuels. And insulin is what dictates the fuel use. So when someone has eaten a meal, a mixed macronutrient meal that it contains starches and sugars, insulin will spike, and that will dictate that the body shifts to sugar burning mode, so to speak. And much of the body's energetic needs will be met almost wholly by blood sugar. In contrast, after that meal we've digested it, we've absorbed it, a few hours later, insulin has now come back down. And now the body shifts away from sugar burning and now starts to rely on fat burning. And that, again, happens because insulin has come down. Now, that shift that happens, going freely from sugar burning to fat burning in the midst of transitioning from a fed state to a fasted state, respectively, that is a phenomenon referred to as metabolic flexibility. And that's a good, healthy state. The ability to shift between energy fuel use based on what you've eaten, because you are, after all, you burn what you eat. And that is reflected in the changes with insulin. You eat starches and sugars, you go to sugar burning mode. You aren't eating starches and sugars, or you're eating a low carb diet, you go to fat burning mode. And that is metabolic flexibility. That happens when someone is insulin sensitive, because when they eat that starch and the sugar and the insulin comes up, give them a couple hours and the insulin has come back down because it did its job. One of its jobs, it cleared the glucose from the blood, and as glucose went back to normal, so too does insulin, and then it's done. In an insulin-resistant person, their insulin is chronically elevated, and let alone when they eat a starch or a sugar, then it's bumped up even higher, and it stays higher for 4 hours. And that whole time, they are stuck in sugar burning mode. So you can imagine someone who's trying to lose weight, they're trying to lose fat. It's not going to happen if insulin is chronically elevated, because they, and this, mind you, I'm presenting this, I'm discussing this in a very kind of superficial way. There's more nuance than what I'm strictly highlighting, but there's enough truth here that there's value. If someone hopes to lose fat mass, they cannot do it if they're stuck in sugar burning. They have to at least have some moments of the day when they're in fat burning. And that's why I don't want to get us too far ahead of ourselves, but that's why I'm an advocate of, I guess I'll say, dietary or lifestyle approaches that help the body lower insulin. The more we live in a state of low insulin, the healthier we're going to be. And frankly, evidence suggests that the longer we're going to live too, insofar as insulin and insulin sensitivity is one of the strongest common factors across the longest lived humans.
Yeah, that's some really important information there, guys. He talked about how when insulin's elevated, you're not going to be able to burn fat. It turns off your fat burning switch. And you've got to be able to burn fat for fuel in order to obviously, be at your optimal weight, but also to really feel good and have all day energy, have great brain function. You've got to be able to turn on that fat burning switch. So really key. Let's talk about the role that insulin plays in inflammation as well, because when you have elevated insulin, it activates inflammatory pathways as well.
Yeah, so that is actually a two-way road, where you have both elevated insulin switching the inflammatory profile of immune cells, making them more inclined to release pro-inflammatory proteins, cytokines, and then thus increasing inflammation throughout the body. But so that goes that direction, insulin resistance to exacerbating inflammation. But it also goes the other way, where if someone just has a purely inflammatory response, that will then drive insulin resistance. And we see this in autoimmune diseases, and this is an example I highlight in the book, but you can take humans who have rheumatoid arthritis, which is this autoimmune destruction of joint tissue. And like any autoimmune disease, there are active and I guess inactive phases. So when the disease is really rampant, their joints are really inflamed and hurting, and then it will subside. During those same peaks and troughs of the immune responses, you can track this almost identical shift in insulin sensitivity, that when the disease is active, this autoimmune inflammatory disease, insulin resistance is up. And then when the disease subsides, so too does insulin resistance, and they just shift back to being more insulin sensitive. And so indeed, that is one of the pillars of chronic insulin resistance. It is inflammation. Without a doubt, chronic inflammation is one of the causal variables of long-term clinically relevant insulin resistance. But that's not quite what you asked. So yes, insulin resistance can drive poor immune function. And that's relevant because if your cells are chronically, there's good inflammation and bad inflammation. And by that, I mean that you need some of these inflammatory mediators in order to heal. Like normal recovery is an inflammatory process. And so we don't want to try to ever shut down inflammation in general. That would be actually lethal. We need to have it happen, but we don't want it up all the time. And if someone is following a lifestyle that's keeping their insulin up, making insulin resistance, that's going to be exacerbating inflammation throughout the body. And then again, it can go the other way as well. So it starts to feed. It's a vicious cycle.
Yeah, that's really interesting, that vicious cycle. So if somebody's having aggravated rheumatoid arthritis or whatever their issue is, it's just going to continue to feed and feed and feed because that insulin is being provoked. And then, when I think about, in a sense, kind of from a, like an evolutionary type standpoint, when I think about why insulin's elevated, like basically when we eat, we're taking in insulin. I think about our ancestors were taking in a lot of food with pathogens on it. And so insulin, basically inflammation's there to help keep us from dying from, some sort of chronic infection, systemic infection that gets into our system. And so when we eat, we're taking in this higher pathogen load. So now the body's producing more insulin, activating more inflammatory molecules to protect us from some sort of bacterial, some sort of pathogen getting into our bloodstream. Would you agree with that?
Yeah, I would. In fact, I think that's a good explanation. I would also add one of the very unappreciated roles of LDL cholesterol, the cholesterol containing and triglyceride containing lipoprotein with LDL.
Yeah.
It is very, very involved in immunity. And what's so interesting is someone's eating a meal and their LDL cholesterol climbs. Perhaps if we look at it through the lens of the context that you just presented, that the body's helping reconcile any pathogens that may be making their way from the guts into the blood. LDL will physically bind pathogens, take them to the liver, and dump them into the bile to be excreted through the intestines. And so one of the unappreciated aspects, greatly unappreciated aspects of LDL is its role in immunity. And it is meaningful. In fact, anyone curious about this, go to PubMed or Google Scholar and just type in immune and LDL, and you'll immediately start getting a lot of hits. In fact, to the point that there are some scientists, biomedical scientists, that think that looking at LDL cholesterol in the context of heart health is actually the incorrect paradigm, that the role of LDL in immunity is the one that should be given more attention.
Oh, that's really fascinating. I always thought of LDL as like a bus carrying vitamin A, phospholipids, coenzyme Q10. I think that's, in functional medicine, that's how we look at it typically, as more of this bus that's bringing all these vital nutrients out to the cell membranes to help enhance healing. But I never actually, I didn't know that it actually binds to pathogens and brings them back to the liver to dump them in the bile. So that's really fascinating, making LDL even more important. I always tell clients I'm more concerned about very low LDL than I am very high LDL. And
good for you.
Yeah. And let's talk about the different patterns. So let's go into like lipid profiles. Most of the listeners are familiar with that: LDL, HDL, triglycerides. Let's talk about the importance of those and how you can look at that and see signs of insulin resistance too.
Yeah. So before I mention that, David, I just can't help it. I have to just mention the relevance of LDL in immunity is in fact very relevant at the moment. And I don't know how explicit we can be here, but some of the best data from China shows that people with the highest susceptibility to COVID-19 infections are those with the lowest cholesterol levels, LDL levels. Yeah. And those with the highest LDL are the least likely to have COVID-19 problems. So this is very timely for people to appreciate. And now they can put it in perspective a little bit, understanding that LDL is so related to immunity. Even in the midst of this global concern, LDL could be a hero rather than a villain. So with regards to insulin resistance and metabolic signals or patterns, there are a few things to mention, and you mentioned the word pattern. Understanding the so-called pattern of LDL is one way to help us know, really appreciate some of the nuance of LDL. I like your perspective in your interaction with patients being more worried about low LDL. That's a perspective that I very much share. Part of the problem with the data on LDL and it being such a terrible predictor of heart disease, some studies suggesting that it's totally irrelevant, some studies suggesting that it might be relevant. It could be that just looking at LDL number completely misses this deeper level of understanding, which is the pattern, so-called, of LDL. So LDL can manifest in varying widths or diameters, size, in other words, volume. And a larger, more buoyant LDL, commonly called pattern A, that is much less associated with formation of atherosclerotic plaques and heart disease. In contrast, a small, dense LDL is a pattern B that's much more associated with atherosclerosis and heart disease. Now, what's interesting is that as much as we look at LDL as being manipulated through dietary fat, that isn't going to be the main variable that changes the pattern of the LDL. And this has been done. Volek and Finney, some of the legendary low-carb scientists, they found that they could take people who were LDL pattern B, the apparently more atherogenic form of LDL, and push them towards pattern A by cutting the carbs and focusing more on fat. It made the LDL more buoyant and less, we suppose, less atherogenic. So that's one nuance of LDL that's commonly lost. If someone's looking at their LDL number from a conventional blood panel after a doctor's visit, they won't know what type of LDL they have. It's very rarely measured, but you can do it. Now, if someone wants to get an idea of their LDL pattern, then they can look at two other lipid markers that have value beyond the LDL pattern. They can also even indicate insulin resistance, and that is the triglycerides and the HDL cholesterol. If anyone listening, go look at your blood panel, and if it's in the units would have to be milligrams per deciliter to do this, but if your triglycerides divided by your HDL cholesterol is lower than about 1.5, that's a good sign. Mm-hmm. That means two things: that you're likely more of an LDL pattern A, and that you're likely insulin sensitive. In contrast, if your triglyceride number divided by your HDL number is higher than around 1.5, that's a bad sign. You're likely more pattern B LDL, and you're likely insulin resistant.
Yeah, it's a good analysis. So basically, if your HDL, typically you're looking at that over 50. You want that to be over 50. And let's say your triglycerides were 75, your HDL was 60, that would be a good ratio because that's less than 1.5, as opposed to if your triglycerides were 150 and your HDL was 60. Now that's, like a 2.5 ratio, triglyceride HDL ratio. It's a sign of insulin resistance there. So
that's exactly right. That's well said. So I say that's the triglyceride to HDL ratio. It really is predictive. It does have a lot of value. And it's something that almost everyone gets from every blood test. So it can kind of be the poor man's method of killing two birds with one stone. You get a better idea of your heart disease risk. And second, you get a better idea of your insulin sensitivity.
Yeah, for sure. Now let's talk about, and you went into detail on how insulin resistance impacts hypertension. Let's talk a little bit about that, how it impacts our ability to, basically retain or excrete sodium and everything else that goes on with the pathogenesis of high blood pressure.
Yeah. In fact, that connection is so strong that if someone has hypertension, like typical hypertension where there's no known aggravating cause, there's no obvious endocrine defect or kidney defect, I submit it's a very safe bet. Insulin resistance is the cause of most instances of primary hypertension, which is the most common form of hypertension. So anyone listening, if they have hypertension, it's probably insulin resistance. And to your point, and I, of course, elaborate in much greater detail in the book than I will right now, but insulin resistance has a really phenomenal and even broad effect on causing hypertension from the level of the kidneys, and even including the nature of the blood vessels themselves, the caliber, the width or diameter of the blood vessels. But high insulin will stimulate a different hormone called aldosterone to be oversecreted or overproduced. And aldosterone tells the kidneys to retain salt, like you said, and then where salt goes, water goes. So the person is basically, they have too much water in their blood. And if they have too much water, that means the volume of their blood is too high. And as volume goes up of blood, then pressure follows it. That's just fundamental physics. So the pressure is higher just because they have too much water. And the kidneys are just waiting to dump this water, but they can't because insulin won't let them. But this phenomenon is so acute that someone can lower their insulin by just making dietary changes within just one day, and they will find that their blood pressure will go down, their systolic blood pressure, the first number, it'll go down like 10 or 20 points in a day just by following a diet that will lower their insulin. And so that's a very rapid effect. Another one I'll mention is that insulin will increase, insulin resistance will not allow insulin to facilitate the dilation of blood vessels. So in a normal blood vessel, insulin, one of its effects, and there are many, insulin will come to the blood vessel wall and it will bind the what's called the endothelial cells, the cells that are the innermost cells lining the blood vessel. And it will induce the production of a molecule called nitric oxide. And this little molecule will then cause the smooth muscle around the blood vessel to relax, and then the blood vessel will dilate. It'll get bigger. And of course, as that volume expands, then the pressure will start to go down because there's just, it's a larger garden hose, but we're not putting any more water through it, no more blood through it. And now, however, in insulin resistance, those endothelial cells become insulin resistant. And so insulin is not as capable at inducing vasodilation. And so when blood vessels should have dilated, now they stay constricted.
Yeah, exactly. So they lose that elasticity that they should have, which is going to cause the blood pressure to go up. And, typically in our society, when people have high blood pressure, they're told to be on a low salt diet. They're not really getting to the root cause. They're trying to treat it downstream because it's not a salt issue. It's an insulin issue. So we need on a low insulin diet, like you were talking about, will actually help the kidneys to be able to get rid of that extra water. And oftentimes, when people go on a ketogenic diet, low carb diet, or when they're fasting, they actually need to take in more salt. They need to be a little bit more intentional about getting the electrolytes because their body starts losing and excreting so much of it.
In fact, David, I'll add to that. One of the unintended consequences of this kind of broad-scale war on salt is that when you restrict salt, you can actually cause insulin resistance. This is a phenomenon documented in humans. When you're restricting salt so heavily, salt is so essential to human function that the kidneys are going to start doing anything they can to conserve whatever salt we have in our blood at the moment. And one of the mechanisms the kidneys will do, one of the processes the body will utilize is increasing insulin to increase kidney salt retention. So insulin's helping the kidneys get more miserly because in this case, the body is desperately holding on to whatever salt it can. And that chronic increase in insulin will start to drive insulin resistance because chronically elevated insulin is arguably the most fundamental cause of insulin resistance. So my point being, one of the unintended consequences of salt restriction is actually causing insulin resistance.
Yeah, for sure. And let's talk about what insulin does inside of a cell, in particular the mitochondria. When we have high levels of insulin, how is that going to impact our mitochondrial health? And for the listeners, mitochondria are what produce the energy within every cell of your body. And you can eat a diet that helps your body actually to get rid of bad mitochondria and helps you create new, healthy, really dynamic mitochondria. But you can also eat a diet like most people in our society are doing that actually damages the mitochondria, makes it less efficient, and aggressively ages your body. So let's talk a little bit about that.
Yeah, you bet. Yeah, so the mitochondria are the so-called powerhouse of the cell. And what is important in that idea is that mitochondria are the site of burning energy, burning nutrients like fat and glucose and ketones and lactate, which are other fuels actually for cells. But mitochondria have, I like you use the word dynamics, mitochondria do have a life and a cycle. These are parts of a cell that are very fluid, where they come together and they pull apart. Insulin prevents well, I should say insulin itself is necessary for normal mitochondrial production and function. We need to have some insulin. But insulin resistance and the chronically elevated insulin prevents that dynamic cycling of mitochondria. And I like what you mentioned a moment ago, where mitochondria get old. The process whereby the cell replaces old parts of itself and makes new parts of itself is called autophagy. So one of the key ways to help our cells maintain optimal function, and then by extension our body, is to help insulin be low enough, at least from time to time, that the cells can go through autophagy. Because insulin is probably the most powerful inhibitor of autophagy. So when insulin is up, autophagy has stopped. And that would include the cell kind of burning through its old mitochondria to replace it with new mitochondria. So we can't, we don't want that process to be inhibited. One of the keys to longevity is autophagy. At least we know this from other animal and insect models, and we can only assume that the same thing holds for humans. And that is all more to my point that the key to long, healthy living is keeping insulin low. Much of that is likely that we aren't inhibiting autophagy constantly. But the reason, David, that's so relevant, because the average person, and you mentioned this, you alluded to this a moment ago, doesn't let that happen like ever. Because they wake up in the morning, and right in the morning, insulin has finally come down overnight, and it has been able to just hum along at its kind of fasting baseline levels. But the average person, one, they ate way too late into the night. They eat up to 10 or 11 o'clock. And so they have a very, very limited window of when insulin has finally been able to come down. But let's just say it was able to come down. Unfortunately, the average American then immediately stops that from happening. Immediately we shut off autophagy, because we start this never-ending, this daily, I should say, spike of insulin, where they wake up and they immediately break that fast with a bowl of sugary junk or toast or bagels or orange juice or whatever. But it's this sugary, starchy bonanza, and that just starts this insulin cycle that basically goes the rest of the day, because they've been told eat a high carb diet and eat 6 times a day, eat 6 meals or snacks per day. And so they eat that crappy breakfast at 7 or 8 a.m. And then a couple hours later, they're ready for their mid-morning snack, and that's going to be junk. Then they're ready for lunch and their afternoon snack. But basically, they're living every waking moment with elevated insulin. And that has, among many, many consequences, they will be inhibiting autophagy all the time, and they will be in sugar burning mode all day, which is tragic, because that's when metabolic rate itself is higher. The body's energetic demands are much, much higher while we're awake than they are while we're sleeping. And so let that be fueled by fat. Let fat fuel much of our daily activity and our daily exercise, or just living. Let fat be the fuel for that. And if insulin is elevated every waking moment, you can't touch your fat. You're sugar burning the whole time.
Yeah, I'm totally with you on that. I think about it. I'm 38 now. And when I was 19 years old, I was a personal trainer, 19, 20, and I was eating 6 meals a day. And just, I thought I had to do it to maintain my muscle mass. And so I would have a protein shake before I went to bed. I wake up in the morning, have the big bowl of, Quaker oatmeal squares with milk and blueberries and peanuts in it, and really literally eating every 3 to 4 hours. And I had constant brain fog, fatigue, joint pain, terrible delayed onset muscle soreness after I'd work out. It was pretty bad for a day or two. Now at 38, I eat 1 or 2 meals a day, all day energy, really great mental clarity, very little delayed onset muscle soreness, even though I'm working very intensely when I work out, and I just feel great, and so, and I'm twice the age. So
Yeah.
it's just a sign that my body is much better at autophagy, like you were saying, the self-eating process. It's so much better at repairing itself and running more efficiently. And the biggest change I noticed was in the brain. We have, I believe, something like 10,000 mitochondria per neuron in our brain. I think it's like 1 to 2,000 per muscle cell and about 5,000 per heart cell. I believe that's about the right range. So
sounds good to me.
Yeah, when you're taking good care of your mitochondria, oftentimes you notice that in your brain. And I've heard that Alzheimer's disease is actually a disease, and we call that type 3 diabetes. It's associated with insulin resistance. We've also heard it's an inability for the brain to go through a process of autophagy and clean out the trash in those neurons.
Yeah. In fact, I love that you're bringing this up. Anyone who wants to learn more beyond our discussion, look up the work of Amy Berger, and she's highlighted this very, very well in a book and numerous talks on YouTube. But yeah, basically what we see in Alzheimer's disease and other neurological disorders like migraines and epilepsy is that there is this phenomenon of brain glucose hypometabolism. And basically it's like this. The brain is an energy hog. It is among the highest metabolic rate organs in the body, so it has a high demand for energy. The problem is the brain becomes insulin resistant, is that it is no longer able to meet that energy. There develops an energetic gap. And because the person is eating a high starch, high sugar diet, eating every 2 or 3 hours, insulin is constantly demanding that the body be in sugar burning mode, and the brain is generally no exception to that. However, so in other words, 100% of the brain's energy in the average person must be coming from glucose because insulin is telling it to, and secondly, because the alternative fuel isn't available. And I'll come back to that in just a second. But as the brain becomes increasingly insulin resistant, its ability to get sufficient glucose to meet its energetic needs is compromised. And now we have, as I mentioned a moment ago, this energetic gap. And this is brain glucose hypometabolism. It is a real phenomenon that is detectable in humans years before Alzheimer's settles in. So we can detect and measure this, quantify this in humans, and certainly confirm it. So this is real. This is not the stuff of speculation. What's so interesting, and I mentioned this alternative fuel, if someone is able to fill that energetic gap with ketones, then the problem starts to resolve. It's most explicitly with seizures. A person who has epilepsy, if they are in ketosis, they may never have another seizure again. Many people, including one of my colleagues just down the hall, they will have frequent migraine headaches, like debilitating headaches, 1 or 2 a week. They will go from having 1 or 2 a week to having 1 or 2 every 6 months. And so there is, even in migraine headaches, some of this energetic deficiency. And then even in Alzheimer's disease, we have evidence in humans to show that if you take someone that is in the throes of Alzheimer's disease, put them into ketosis rapidly, you can detect immediate improvements in cognition across a variety of tests. So let the brain be a hybrid. Like human metabolism is a hybrid, burning sugar or fat. With the brain, its hybrid fuels are blood sugar and ketones. But we have to give the ketones to the brain. And you can only have ketones in your blood if the body is in fat burning mode, because ketones come from fat burning. And so thus the person who's listening already knows that means insulin must be down. And that is why you see so many, this explosion in this area of ketogenic diets as a therapy for Alzheimer's disease. Now, my lab has actually taken our first steps into this phenomenon. We literally just this morning submitted for review, which means to say that it'll be months before it's actually published because it's such a slow process. This study where we analyzed the gene expression of human brains, so post-mortem brains from people that had no Alzheimer's disease and brains from people that had Alzheimer's disease. And what was so fascinating is that in the Alzheimer's brains, virtually every gene associated with glucose use was significantly lower than normal. So this is genes involved in glucose uptake into the brain tissues, the oligodendrocytes, the microglia, the neurons. They were compromised. So glucose uptake was significantly down, and glucose catabolism, like the genes involved in actual glycolysis, were also significantly lower than the normal brain. However, when we did the parallel analysis of genes involved in ketone catabolism, ketone uptake, and ketone burning, they were normal in the demented, in the Alzheimer's brains. So all more evidence surrounding this idea that in Alzheimer's disease, glucose metabolism is compromised, but not ketone metabolism. So the best thing we can do for our brains, and indeed one of the reasons I personally adhere to a low carbohydrate ketogenic diet, is to help my brain work and to help fight off Alzheimer's disease, one of the few diseases that I am very much afraid of.
Yeah, it's a disease nobody wants to get. My grandmother unfortunately passed away with dementia. And so I saw, what happened there. And yeah, we got to do everything we can to protect our brain. That's for sure. Now, I've heard you talk a little bit about the difference between brown fat and white fat. And I think that would be really good to discuss as well with our listeners.
Yeah. I'm glad you brought that up because it's such an interesting topic. So when people think of fat tissue, we typically just think of fat as this inert storage depot, basically a fat cell that is just pulling in fat or glucose and turning it to fat, and then just holding on to it, just storing energy. And then when the body needs the energy, like for example, when insulin is low, now it can start to release the energy to be burned by the muscles, for example. And that is true. That is typical body fat, kind of acts just like I described. But once again, it is totally at the whims of insulin. When insulin is up, the fat cell is pulling in energy to store. When insulin is down, it is giving up its energy to be used. However, there is a type of fat in our body called brown fat that does not behave the same way. Now, firstly, the differences are obvious, and I do mean obvious. When we do these kinds of studies in animals, you can see the actual difference, and the same thing goes with humans, in the color and appearance of the fat. Normal fat tissue, like the fat that we pull from like in my lab, we do what's called fat biopsies, and we pull a little piece of fat from right by the belly button. That is very kind of whitish, yellowish fat. Just like you'd think when you look at a steak, or the fat in the meat that we eat, it's white. Mm-hmm. Brown fat is much more enriched with mitochondria. In fact, some of what gives the muscle of the meat that we eat its reddish appearance, the mitochondria is this kind of reddish brown structure in the cell, and brown fat has much more of those mitochondria. Now, we'll recall mitochondria are involved in burning things and burning energy, burning fat and glucose. And so these brown fat cells are involved in breaking down nutrients, burning energy, but not because the cell needs the energy. In other words, it's not because the person's exercising a lot that the brown fat cells are burning through so much fat and glucose. No, it's in fact a very wasteful process, although metabolically that becomes an advantage in our environment. But the brown fat is burning fat and glucose just to create heat, which is an inefficiency. We speak about efficiencies and inefficiencies. In our environment of a hypercaloric diet where we all have plenty of food, we all have enough fat to burn all the time, being a little wasteful is actually a good thing because it gives us some of this kind of metabolic wiggle room where we don't have to be worrying about every single individual calorie we eat. If we can kind of hijack our brown fat cells to be more active, or shift a slight sort of new phenomenon I'm introducing we can help our white fat cells act a little more like brown fat cells. It's this process known as beiging. Then we have a higher metabolic rate. These fat cells suddenly stop just storing energy, and now they just start burning it just to increase body heat, body temperature. And one of the ways we can kind of hack that process of converting our white fat into brown fat, one is through just cold exposure. You can sit in 18 degrees Celsius water, which is not very pleasant. Or you can increase your ketones. We have in review a manuscript right now where we outline this humans that when a human is in ketosis, the metabolic rate in their fat cells goes up about 2 or 3 times, likely because it's shifting its profile. It's going from this very low metabolic rate, typical white fat cell, to this much higher metabolic rate, brown fat cell. So that's something we can exploit just by manipulating our diet.
Which is really interesting too, because one of the ways that you get in ketosis is through intermittent fasting or fasting. And so most people think of that as a way that you would slow down your metabolic rate. But what we're seeing here, obviously, with this brown fat activation is that it's actually speeding up that metabolic rate.
Yeah, and you see this in human studies. Short-term fasting, even to the point of 2 or 3 days, which is more than short-term by my standards, but that actually increases metabolic rate. So this idea that fasting, intermittent fasting, is going to slow metabolic rate, it is absolutely false. That does not happen. We can measure this phenomenon in humans. Metabolic rate goes up.
Now the key there is when you do eat, you got to eat well. You got to
yes,
calorie restriction approach. You are trying to eat a lot of food. I call it feast famine cycling. So when you eat till you're satiated, and then fast, and then wait till you're hungry again. And
yeah, well said. Well said. I like to say the most important part of a fast is how you end it. And I worry that sometimes people look at fasting, this real explosion in the interest in fasting, intermittent fasting, which I think is a good thing for us to be interested in. But they use it as sort of a binge and purge cycle where they fast all day, and then evening comes around and they're so hungry and they've not planned well for ending the fast, and they just eat. They binge on all kinds of junk. They make themselves painfully full. They regret it. They have remorse. They sleep poorly, and they wake up with this conviction: not today. I'm going to fast all day to make up for what I did last night, and then they end up doing the same thing that night. So how we end the fast is the most important part of the fast, and I encourage anyone just to really have that meal planned. Have a goal in mind. Eat a certain amount, and then force yourself just to say, I'm going to stop right now and then see how I am in 10 minutes or 15 minutes, because very, very likely the person they'll be very surprised at how little they actually need to eat once they've ended their fast. It's just more habit and, dare I say, addiction that drives them to eat far more than they should have when they've ended their fast.
Yeah, it's really well said. And, it's certainly somebody that's doing it incorrectly can actually trigger an eating disorder. So, you need to do it appropriately. Well, let's talk about an insulin-friendly diet, what your best recommendations are for that.
Yeah. So I elaborate more in the book, of course, but I've tried to distill it to what I think are the 4 pillars. And they are, if I may say so, sort of cleverly worded here, but let's just kind of go through them. The first one, I like to, and I think it's first for a reason. I put it first for a reason. It is control carbohydrates. So be smart about the starches and the sugars that you're eating. Limit them greatly, much more. Limit them to a much lower degree than what you're currently eating. And depending on the person's underlying insulin sensitivity, what they see from their triglyceride to HDL ratio, for example, I would say that number is best heavily scrutinized to about 50 grams per day. But if someone has a pretty good triglyceride to HDL ratio, then they can certainly be more liberal with that number, and they don't need to cut it to such a low level. But the first step is control carbohydrates. Stop drinking fruit juice. Stop eating bread and cereal and crackers and chips, and focus on real sources of carbohydrate if they want them, namely fruits and vegetables. But eat them, don't drink them. And I just generally stop there. There are some other kind of fine levels of fruits and vegetable scrutiny, but we don't even need to get into that. The second variable is prioritize protein. Make sure if you want to age well, eat enough protein and get the right kind of protein. And so a person who just needs to have a general range, although I hate being this specific, but there is a number. Stu Phillips in Eastern Canada found that 1.6 grams of protein per kilogram of ideal body mass. So if someone's very overweight, we would want to say ideal body mass. That's an optimal range for protein consumption. And then the source matters. And now I am very I'm very wary of this explosion of interest and availability of plant protein-based foods. And I don't want to ruffle feathers because I know this can be a sensitive topic. So I'm going to say this as objectively as I can. But clear, plant protein is inferior to animal protein in every way. The amino acid profile is not comparable. It is far superior in animal proteins. And animal proteins also are cleaner, and that might be surprising to say, but all plant proteins, to my knowledge, have molecules in the plant protein that will inhibit the body's ability to digest the plant protein, like phytic acids or tannins or trypsin inhibitors. These are found in all plant proteins, and that further exacerbates the lower biological value of the plant protein. And then I would also add, there was a study done by a nonprofit organization called the Clean Label Project, and they analyzed protein supplements for the presence and levels of heavy metals, things like lead and arsenic, known to be harmful to humans, and plant proteins were the biggest offenders. And that's a consequence of basically what we've done here. Plants are so naturally so deficient in protein that when you're trying to get protein from a pea, you've got to get, let's say 1,000 proteins together to get one serving of protein, 1,000 peas together to get one serving of protein. And the protein is what you want to get, although again, it's not as high value as you think. In the process of concentrating those peas, you're also going to get things you don't want, like the natural minerals or metals that every plant is pulling up from the soil. But when you're just eating peas, it is such an insignificant amount. It's so little. But when you're now concentrating the peas to get to the protein, you're also getting these metals with them. And so you have potentially what they call toxic levels of these heavy metals. So anyway, that's a long belabored point. Prioritize protein, really focus on animal proteins. And then that kind of touches on my third pillar, which is don't fear fat. And fat and protein come together in nature. The best protein sources, animal, come with fat. And fat helps the protein digest better. The bile acids that we get released when we eat fat actually improve protein digestion. And so there's a reason that fat and the best proteins in nature come with fat. It helps, not only are there studies to show that digestion is improved, but it also makes the protein more anabolic. In a study in humans, that when you mix protein and fat together, you have a better muscle anabolic response than just the protein alone. And then my fourth point is fast. Don't feel the need to eat every moment of the day. I'm a strong advocate of looking at one of the meals on the ends of the day and cutting it out, at least from time to time, if not every day, then at least maybe a few days a week. Let the body have a period of fasting. When insulin has come down, it might be a little uncomfortable sometimes, but every person has enough fat to fast. Even lean guy, you and I are fairly lean. Oh, yeah. We could easily fast for days. We have hundreds of thousands of calories stored as energy just waiting to be used. So when I see someone about to go on a little hike, here in the beautiful mountains of Utah, I may see an overweight person and they will have energy bars and energy drinks. And I'm just thinking, how tragic. Yeah. All they needed to bring was some maybe water and maybe some salt. Yeah. Let your body use its own energy. Every one of those fat cells is basically a little energy bar just waiting to be cracked open and used. And it can only be used if insulin is down, more to my points earlier. But anyway, the fourth pillar to improving insulin sensitivity, keeping insulin low, don't be afraid of fasting.
No, I love that. And what's a good fasting window? If somebody's looking to stimulate autophagy, I'm sure you get this all the time. For autophagy, we really don't have blood tests and measurements.
You're right.
To look at that. But and everybody kind of has different ideas, everybody in this industry. But what's a good window that somebody should look to do, let's say on a daily basis, or maybe on a weekly basis, in order to get a decent level of autophagy?
Yeah. So David, I like that you prefaced this question by emphasizing the fact that we don't know.
Mm-hmm.
There's just, it is so, there's no clear marker for showing activation of autophagy. Speculating somewhat, I would say that a decent marker is the presence of ketones, because ketones themselves are a consequence of pronounced catabolism, like, in other words, fat burning, low insulin. So I like to think that when ketones are starting to come up in the blood, so too is autophagy. And there's some evidence to suggest that that's a pretty good correlation, but please everyone know I'm not stating that with any high degree of authority. It's probably a marker of autophagy. So if we base it on that, in the average person eating a typical American diet, if they fast for around 16 hours, they start to get into ketosis. And so I kind of look at that number, and I think an 18.6 is a nice, easy way to probably have some autophagy from time to time. And of course, if you couple that with a low-carb diet, well, then you're cooking with gas, and you're probably in autophagy almost all the time.
Throw in some exercise maybe right there at the end of the fast.
Yep, well said. That's right. Just to accelerate things even more along that, pushing the process of autophagy. Yeah, so an 18.6 protocol works pretty well, but then I would also say I do think there's value in a true full 24-hour, at least food fast once a week.
Yeah.
And I generally like to do that on Monday. And that's a little practical just because typically over the weekend, it's hard not to indulge a little more, even if I'm still really strict. I'm just more at home. I'm out with the family more. It's very likely that I've had some more indulgence. And I just sort of like to reset, if you will, and just kind of take over discipline again, and then have a nice, clean, full fast on every Monday, basically.
Yeah, absolutely. Ben, I really like that. In fact, that's always one of my goals when I'm working with somebody. If you can fast, do a 24-hour fast and still be productive and work and do the things that you're supposed to do that day, that's a really good sign of metabolic flexibility. And I think it's something that it's a great goal to accomplish. And even very lean people can accomplish this. I know for myself, I'm usually around 8% body fat, and I do a 24-hour fast at least once a week, sometimes twice a week. Just for the brain benefits. I feel so much better. My heart rate variability is better. So a sign of parasympathetic activity. I sleep better. I get just more restorative rest. My body's adapted to it. But if you're out there and you start with what Dr. Ben was talking about there, 18.6, something in that along those lines, over time, you'll build that fasting muscle and you can be able to push it to that full 24, which is really like a dinner to dinner fast or a lunch to lunch, something along those lines. And you'll notice it's not quite as hard as you think. And doing that once a week, that's something that a lot of the natural health pioneers throughout the years, people like Paul Bragg for Bragg's apple cider vinegar, he talked about doing a one-day fast. Jack LaLanne talked about doing a one-day fast. A lot of these people, these ancient healers, talked about doing a one-day fast every single week as being one of the best things you can do for your health. And when it comes to stabilizing your insulin levels and helping activate autophagy, it certainly is. And the cool thing is it doesn't cost you anything. It's really just making a decision and doing it and going for it from there. And then when you couple that with, again, with exercise, I like to get the exercise in. I like to take a cold shower right at the end of the workout, or at least like I'll start it warm, but then get in, make it cold like the last 30 to 60 seconds. Yeah. Activate that brown fat and really, really drive down the blood sugars and get that insulin stable. So really good.
Yep.
Well, any last words? I know we're running out of time here. Let's talk about real quickly, actually, about your top 5 favorite foods that you're consuming on a regular basis. And then just last words of inspiration.
Okay. Good question. My top 5. So I'm a fan of red meat.
Yeah, me too.
Really, it's one of the staples that I try to have in my home. And it's, as a father, that's something I want my kids to eat. It might sound funny to say, it's certainly Buck's convention or dogmatic thinking of nutrition and diet. I want them to eat their meat first. And then whatever they pick on their broccoli and et cetera, that's great. It's fine. It adds some color to the plate. But I know the broccoli isn't going to make them grow strong and healthy. It'll be what's in that red meat. So I'm a big fan of red meat. I personally love hamburger. And my favorite dinner is just, I buy my beef from a local, actually he's a professor in the Russian department, and he just has a small little ranch on the side, so to speak. And so I buy my meat from him. But we make little hamburger patties. We mix in an egg with the hamburger, and then we split it out. I love it. And
the egg helps it like bind together.
That's right. That's exactly right. Yep. And it gives it a little kind of crispy to it as well. Yeah. It's delicious. That's Anyone who is going to grill some hamburger, add an egg and mix it in next time. So hamburger and eggs are actually probably number two. I love eggs. I actually drink them raw sometimes for breakfast if I feel like I need something. Not that I'm telling anyone to do that. I know that scares some. But I will make, when I make breakfast for my kids, which I do every morning, it's very commonly kind of low carb waffles or low carb pancakes or even crepes, although the crepes are kind of hit or miss. But I just keto load those things
now too. They have keto pancakes. Yeah, we make those as well.
Yeah, I load them with eggs. So eggs are a staple. We go through, in my little family of 5, we probably go through 3 dozen eggs a week, if not more, frankly. So I'm a huge fan of eggs. The third, I don't know, I'm kind of running out. Eggs and meat are my go-to. I will say, at the risk of sounding kind of self-congratulatory here, but I made a meal replacement shake with a couple of my brothers, and I won't go any more detail than this, lest I sound like I'm a shill. But
go ahead. You can.
Well, anyone who wants to learn more, we created a website. We sell it online. It's Get Health, and that's HLTH, GetHealth, and they can learn more about it. But I actually rely on that shake pretty often because when one of my brothers was interested in low carb diets, and he had just left the supplement industry and said, there aren't a lot of shakes out there. And I'd never really cared about that. But there is something, I mean, one of the beautiful things of a low carb diet is there aren't a lot of fake foods you can eat. You have to rely on real food. That's a good thing. It's also a little inconvenient. And so when we started looking into low carb shakes, the sad fact was that almost every one of them was even when they were low carb, they were much higher carb than I wanted, but they were almost always built on plant protein. It was pea protein or pumpkin seed protein, and those are not healthy, and they taste terribly. But I will say, from the perspective now having been involved in actually manufacturing a shake, one of the reasons shake manufacturers want to use plant protein is that they are so much cheaper. A fraction of the cost of, say, like egg and whey, which are the best proteins and the 2 that we used in our shake, but they're so much cheaper. And when you have plant proteins, you can brag about it on your label and say, this is, vegan friendly or whatever. And so it lets you kind of virtue signal to the potential buyer and save money because it's so cheap. We didn't take that easy way out, but we still kept the price down. So anyway, I rely on that shake. Anyone who wants to learn more, again, the name of the company is Health Code, HLTH, and the site is GetHealth,
Perfect.
So those are my staples.
Yeah, we'll put a link. And
those are my staples.
I'm a big fan of smoothies too, because, in our society, we're so on the go.
Yeah.
And really, to be able to digest meat well, unless you just have a robust digestive system, you need to be like sitting down and relax. You need to be able to produce a lot of stomach acid, bile, right? And if you're just on the go, it's much better to have a protein shake, a good, high quality protein shake like that, where the blender has already done the job of the digestive systems. Now you're just absorbing the nutrients. So if you tend to have a really busy schedule, I always tell people, eat your largest meal when you're most relaxed, right? Like a family dinner type atmosphere.
Well said.
Yeah,
that's
and that will help you.
Well said.
Yeah, and that's really where the role where those types of protein shakes come in. That can be really helpful when you're on the go. So really good stuff. Yeah, we'll have a link to that. And the book is Why We Get Sick, The Hidden Epidemic at the Root of Most Chronic Disease and How to Fight It. We'll have a link below as well, so check that out. Dr. Ben, it's Bikman, right? Is that how you pronounce your last name?
Yeah.
Bikman, okay. Yeah, Dr.
Just
Ben.
call me Ben, though. Everyone calls me Ben. And David, I have 7 older brothers, so I've been called everything.
I'm sure. Yeah. You can just imagine with the last name, Jockers.
Yeah.
I was called Jock Strap, things like that growing up playing sports. Yep. So I've been called it all as well. And we can find you also on Instagram, right? Is it just your name on Instagram, right? So we'll have a link there as well.
I'm fairly active on social media, and it's never personal stuff. It's just me sharing insights into human metabolism. And on Twitter and Instagram, which are my main ones, it's just Ben Bikman. No C, just Bikman, Ben Bikman, PhD.
Awesome. Well, thanks again for being on the podcast. For those of you guys that are listening, I know you got a lot of nuggets out of this. So go out, start putting it in action, and improve your life. Be blessed, everybody. We'll see you on a future podcast.